Hello everyone. Once again, welcome to IPv6 series. Guys, in IPv6 series, today we are going to understand packet flow between two devices. You already know packet flow in case of IPv4, and today you will learn packet flow in IPv6. This video is going to be very useful, very helpful for all network engineer. Nowadays we are shifting from IPv4 to IPv6, so it is very important for you to understand the packet flow, because packet flow is the base. Without understanding packet flow, you cannot understand the routing, right, in case of IPv6. So soon we are going to start routing in IPv6. So that's why today I am going to make you understand packet flow of IPv6. But before starting the packet flow, let me make you understand one type of multicast address of IPv6, that is solicited multicast address. Because this is very important, solicited node multicast address. In NDP we had discussed some types of message till now, like in NDP, as you know, NDP is an neighbor discovery protocol. NDP, in NDP we have discussed neighbor discovery protocol. In neighbor discovery protocol, till now we had discussed two types of message. First is RA message, router advertisement message, and second is RS message, router solicitation message. And today we are going to understand two more types of message of NDP. That is, let's say, third type of message, NS message, neighbor solicitation message, and fourth type of message is NA message, neighbor advertisement message. So today you will understand these two types of message of NDP, right? You already know what is the use of RA message, router advertisement message, and RS message. If you have not watched the previous video, please start watching IPv6 series from the day one, guys, right, to understand everything. Okay, so today you will understand these two types of message, NS message and NA message. Okay, so without wasting our time, let's begin. See, first of all, see what is solicitation node multicast address. Guys, before discussing what is the purpose of this multicast address, I will make you understand the purpose of this multicast address as well. Before that, understand how router create this multicast address. Let's say if you are configuring one unique local IP address on the interface of router, that means that interface will have one solicited node multicast address. If you have configured two unicast address on the interface, that means that interface will have two solicited node multicast address. Done. Now concern is how router is going to use this multicast address. We will understand why router is going to use this multicast address and how router is going to use this multicast address. First of all, understand how router create this multicast address. So for solicited node multicast, we have reserved how many bits? 104 bits. Means we need how many more bit? 24 bits more is required, right? Till now I said that when we configure one unicast IPv6 address on the interface of router, you will have one multicast address, that is solicited node. If you have two unicast IP address on the interface of router, that means you have two multicast address, two solicited node multicast address. Okay, but till now here we have ff02 double colon 1 colon ff00 colon 000/104, means we need 24 bits more, because total length of IPv6 address is, as you know, 128 bits. So we have 104 bits over here, and we need how many bits? 24 more bits over here to complete this multicast address. To complete this multicast address, we need how many more bits? For 24 bits. Always keep in mind, first 104 bits will be ff02. As you know, all multicast address start from ff02, right? This is reserved for multicasting. After that it will be double colon 1, then ff00 colon 0000 slash 104. Now what is last 24 bits, guys? Last 24 bits is the multicast, is the 24 bits of your unicast IP address. Let's say I have one router over here, and this router have one interface. On this interface I have configured one IP address, that is, let's say this is f0/0, and here I have configured the IP address 201 colon db8 colon anything 1 colon 1, or we can say directly db8 1 double colon or single colon 1 colon 1 2 3 4, let's say colon 1 2 3 4, let's say colon 5 6 7 8 colon ABCD. Let's say this is IPv6 address of this interface of router. Okay, this is router, and the IP unicast IP address of this interface is this one, 2001 colon db8 colon 1 colon 1 colon 1 2 3 4 4 colon 1 2 3 4 colon 5 6 7 8 colon ABCD. Now what will be the multicast address? Multicast address will be, see, first 104 bits will be same, ff02 colon double colon 1 colon ff. After that last 24 bits means, this is, wait guys, control C, copy. See, this is your 16 bits, right? 16 bits, and this is your 24 bits. Yes or no? This is your 24 bits. So this 24 bits will be the last 24 bits of solicited multicast address. So your total multicast address will become what? Multicast address will become this one, ff78 colon 78 colon ABCD. This will be the multicast address. ff02 double colon 1 ff78 colon ABCD. Last 24 bits is from unicast IP address. Let me show you the practically. Okay, let me take one router over here, and on this router I am going to configure one IP address. Let me turn on the device. And I am going to configure the same IP address, let's say over here on the f0/0 config t interface f0/0 IPv6, say no set, and IPv6 address. What happened? Interface f0/0 IPv6. This router is not supporting IPv6. Let me take another router, this one. Here I am going to configure one IPv6 address on, let's say, f0/0 interface f0/0 IPv6 address 2001 colon db8 colon 1 colon 1 colon 1 2 3 4 colon 1 2 3 4 colon 5678 colon ABCD slash 64, let's say. I have configured this IP address over here. Let me say no set. And now, so IPv6 interface F0/0. See, this router have joined only this multicast group. Let me connect this router with the switch. Now line protocol of this interface will come up, and now you can see this router, this interface F0/0 interface of router have joined this multicast group as well. After that, this multicast group and this multicast group. See, we have actually two unicast address on this interface. That's why we have two solicited multicast address, one for link local, and one for the global unique address, global unicast address, that is this one. Okay, see, this address is till here it is reserved, and last 24 bits is 78 ABCD, 78 ABCD from my unique global unicast address. Okay, so hope it is clear that how router create solicited node multicast address. Like if you will see the link local address, so let me copy the link local address over here, and I am going to paste the link local address over here. So tell me what will be the solicited multicast address of this interface. FF02 double colon 1 colon FF, and after that last 24 bits will be from the link local address. So this one is last 24 bit will be 6 C, after that colon 0. So this will be what? The solicited multicast address. If you want to verify, you can verify. See, this is the solicit address for link local, that is FF02 double colon 1 colon FF6C colon 0, and this is my global unicast address. So if I will paste this address over here, so you tell me what will be the solicited node multicast address. FF02 double colon 1 colon 1 colon FF, after that last 24 bits from the unicast address, that is 34. What is the address? Let me verify once again. This one is the address, complete address. This is right. So last 24 bit will be 78 colon ABCD. You can verify it also. You can see this solicited multicast address, right? So till now we had discussed only one thing, that how router create solicitation message. Now let's understand what is the purpose of solicitation message. I am going to delete this portion from here. See, purpose, I am going to discuss now purpose of never solicitation message. So guys, in case of IPv4, let's say I have two computer 1 and computer 2. Both are directly connected with one Ethernet cable. PC1, and let's say this is PC2. In case of IPv4, let's say I am using one IPv4 address over here, that is 10.1.1.1, and here 10.1.1.2. MAC address of this PC is, let's say, 0A, and MAC address of this PC is, let's say, 0B. So whenever PC1 need to send some traffic to PC2, PC1 need MAC address of PC2, yes or no? When you will ping 10.1.1.2. First, PC1 will resolve MAC address of 10.1.1.2 by generating what? By generating one ARP message, right? You know ARP is an broadcast message. PC1 will generate one ARP request, then PC2 will generate one ARP reply. After that, PC1 will have the MAC address of PC2 and it will maintain what? ARP table, ARP table. In ARP table, they is going to maintain what IP address of destination device is this one, and MAC address of 10.1.1.2 is 0B, right? Like this, PC1 will resolve MAC address of PC2. Guys, in case of IPv6, we don't have any broadcast message, right? We don't have a term like broadcast in case of IPv6. In IPv6, let's say here on PC number 1, I am using one IP address that is 2001 colon DB 8 colon 1111 double colon, let's say 1/64. This is the IP address of, let's say, PC1. And in the same way, I am using one IPv6 address on PC2, that is, let's say, this one, double colon 2. Done. MAC address of PC1 is 0A, MAC address of PC2 is 0B. Now, again, if PC1 want to send some data to PC2, PC1 need MAC address of PC2. But here we don't have ARP. We have NDP message. Let me introduce you to third type of NDP message, that is NS message. PC1 will send what? NS message. NS, never solicitation message to PC number 2. In never solicitation message, source MAC will be the 0A, the MAC address of PC1. Destination MAC will be the multicast. Now question is how to identify, how PC1 will find the destination multicast address. Guys, in IPv4 also we have three types of multicast, three types of MAC address. First one is unicast MAC address. Unicast MAC address, that is MAC address of an interface, that is physical address and globally unique address, right? That will be provided by the vendor, right? Second type of MAC address is multicast MAC address. Multicast MAC address, like CDP is using one multicast MAC address, VTP is using a multicast MAC address, STP is using multicast MAC address, and we have broadcast MAC address, that is all F. Broadcast MAC address, that is all F. But in case of, let's say, ARP, when PC is generating ARP, in the ARP request, destination MAC will be broadcast. In the same way, in IPv6 also we have unicast MAC address and multicast MAC address. In multicast MAC address, as you know, total size of MAC address is 48 bits. So 16 bits will be always reserved. 3333. It will be always reserved in the multicast MAC address, and last 24 bits and last 32 bits, sorry, total size of MAC address is 48 bits. So last 32 bits will be XX, and this is nothing but the last 32 bits of multicast address. Last 32 bits of multicast address. So what will be the multicast address of PC1? Here we have configured one unicast address. So this PC will have one multicast address. Yes or no? This is nothing but the multicast MAC address. Here let me write. Multicast MAC address. MAC address, right? Now tell me what will be the, you calculate what will be the multicast IP address of PC1. What is the multicast MAC IP address of PC1? Solicited multicast address, that will be FF02 colon FF02 double colon FF00 and column 1 slash 64 slash, this is the multicast, sorry, this is the multicast address FF, because this is reserve and this one is last 24 bits is of unique address, right? So here what will be the last 34 bits? That will be the multicast MAC address. So a PC, when you configure the unicast address on the interface, on the IPv6 interface, it calculate solicited multicast address and multicast MAC address. Multicast MAC address. So let's say this is what, this is my unicast IP address. This one is my multicast IP address. So what will be the multicast MAC address? Multicast MAC address, this is like 000. Multicast MAC address will be 3333. After that, last 34 bits from the multicast address. So multicast address is this one. If you will expand this address, so all value are hexadecimal value. Each value carry how many bits? 4 bits. This is 32 bits, 16 bits, and this is 16 bits. So total 32 bits. So it will be FF 000001. This will be what? Multicast MAC address of PC1, right? In the same way, PC2 will have also one multicast IP address and multicast MAC address. So PC2 multicast address will be FF 02 double colon FF 00 colon 0002. This will be the multicast IP address, and multicast MAC address will be 333.F00.0001. This will be the multicast MAC address. This is MAC address and this is IP address. This is MAC address, this is IP address. So in when PC1 will send what? NS message. PC1 will send NS message when we will type ping 2001 colon DB 8 colon 1111 colon double colon 2 on PC number 1. First of all, PC1 will generate what? One solicitation, neighbor solicitation message, right? To find what is the purpose of neighbor solicitation message? To find the MAC address of PC2. PC maintain neighbor table like in GNS3. If I will turn on the device, let me turn on the device. And on any router, if you will check the IPv6 neighbor, so in neighbor table, like neighbor table is like your ARP table in case of IPv4. IPv6 device maintain neighbor table, IPv6 neighbor discovery table. That is similar like your ARP table. There will be information of IP address, IPv6 address, and MAC address. So first, before sending the actual ICMP traffic to PC2, PC1 will resolve the MAC address. It will send neighbor solicitation message. In neighbor solicitation message is similar like your ARP request, and neighbor advertisement message is similar like your ARP reply message, right? So in neighbor solicitation message, source will be what? Source MAC will be the MAC address of PC. Source MAC will be the MAC address of PC. If I will talk about the content of neighbor solicitation message, so in neighbor solicitation message is nothing but IPv6 ICMP version 6 message. It is an ICMP version 6 message. ICMP version 6. Okay. Inside the ICMP version 6 message of NS, neighbor solicitation message, there will be source IP address and destination IP address. Source IP address will be what? IP address of PC1. destination IP address will be what? IP address of PC2, because PC1 know the destination IP address. Source MAC will be what? Source MAC will be the MAC address of PC1, and destination MAC, source MAC, let me write over here, source MAC. Source MAC will be 0A, destination MAC. Destination MAC will be multicast MAC address of PC2, because PC1 can calculate the multicast MAC address of PC2, because PC1 have destination IP address, so it can calculate the destination multicast address. It can calculate the destination multicast MAC address also from the IP address. Process is same, 333.ff02. This one is the MAC address of PC2. Like how PC calculate MAC address. Last 32 bits will be the last 32 bits will be the multicast address. So here destination MAC will be 333.ff00.0001. This will be the destination MAC address in NS message. Source IP address will be the IP address of PC1. Source IP will be what? 2001:DB8:111:1, and destination IP will be the IP address of PC2, that is 2001:1111:2. And inside the ICMP version 6 message, there will be target IP address. Target IP. And target IP address will be the IP address of PC2. PC2 IP. Yes or no? So this is the actually our NS message, neighbor solicitation message, that PC1 will send to PC2. After that, PC2 will generate what? NA message, neighbor advertisement. NA message, and NA message is similar like your ARP reply message. In NA message, source MAC will be the MAC address of PC2, destination MAC will be the MAC address of PC1, and source IP will be the IP address of PC2, destination will be the PC1 IP address. Like this it will work. Let me show you the practically, guys. Here what I am going to do, I am going to configure one IPv6 address on PC1 and on PC2. Let's say here I am going to configure IP interface F0/0, IPv6 address is 2001:DB8:1234, let's say :1/64. I've configured this IP address over here. And if you want to check the MAC address, let me say no sat as well on the interface F0/0, say no sat. No sat. Now, so interface F0/0 include by, this is MAC address of PC1. Let me copy it and let me paste it over here. This is MAC address of PC1. IP address of PC2 is so IPv6 interface F0/0. This is IPv6 address of this PC, and the multicast address of this PC is this one. You already know how PC calculate this multicast address. This is multicast address FF02:1 FF001, because here you can see the last, it is taking last 24 bits from the unique global unicast address. Done. Now I am going to configure, and till now if you will check the neighbor table, so IPv6 neighbor, in the neighbor table there is no any entry, right? So it means PC1 don't know what is the MAC address of PC2. Now let me configure IP address on PC2 first. Config T interface F0/0 no sut, and IPv6 address is 2001 colon db8 colon 1234 double colon, let's say 2/64. Done. I have configured this IP address over here. So let me copy the MAC address first. So interface F0/0 include device. This is MAC address of PC2. Let me show you the IP address of PC2. This is the IP address of PC2. And this PC will also have one multicast address. So IPv6 interface F0/0 multicast address is this one. Now I am going to capture the link between PC1 and PC2. So IPv6 neighbor, there is nothing. Let me capture the link. And from PC number 1 I am going to ping PC2. Ping 2001 colon db8 colon 1234 double colon 2. Ping is successful, and so IPv6 neighbor. Now you can see the table, neighbor table. In neighbor table, this is the IP address of which device? This is IP address of PC2, and this is MAC address of PC2. You can see this is the MAC address of PC2, 227C CA02 227C.000, right? And this is link local address. If I will take you on PC number 2, so here, so IPv6 interface brief. This is link local address of PC2. So link local address and global unique address, both MAC address is same. You can see PC1 have no information. Now let me take you to capturing. Here is my capturing. See, first router have sent what? Neighbor solicitation message, NS message. Who have sent this message? 2001 colon db8 colon 1234 double colon 2. Not for this, from, you can see, let me open this message here and see, in Ethernet header, source MAC address is the MAC address of PC1 CA01015755C0000. Done. And destination is, this is important, destination is what? Destination is multicast. Destination MAC is what, guys? This is very important. 33FF000000. Now you tell me what will be the destination, what will be the multicast address of PC2, multicast MAC address. This is the multicast IP address. Multicast MAC address will be 3333 dot last 32 bits it will take from the multicast IP address. So this is, if you will expand this address, it is 000, and this is how many bits? This is 16 bits, and this one is 16 bits. So here complete multicast MAC address will be FF00 dot 0002, and now you can verify it. See here, destination is 33FF 00002. So destination will be the multicast MAC address, and PC1 have capability to calculate the multicast MAC address of destination device, because PC1 have information about destination IP address. From the IP address, from the global unicast address, you can calculate the multicast address as well, and the multicast MAC address as well. Multicast address, multicast IP address means solicited node multicast address, and multicast MAC address, you know, already know how to calculate multicast MAC address. So PC1 have sent one NS message to PC2. In the NS message, as you can see, source MAC is the MAC address of PC1, that is CA 01 57 5C 0000. Destination is multicast, that is 333. After that FF 0002. This will be the destination MAC address. Now what will be the source IP address? So source IP is IP address of PC1. Source IP is IP address of PC1. Source IP address will be the IP address of PC1, that is 2001:DB8 :1234 :1, and destination IP address is, you can see destination IP address is FF021, means multicast address of PC2, that is FF02 :1 FF00:2. This is this MAC address. So let me copy it from here, multicast address, and let me paste it over here. It will be the destination IP address. After that, in the actual ICMP, if you will open it in detail, actual ICMP message. So in actual ICMP message, you can see the link local address is the link local address of PC1. This is neighbor solicitation message. And guys, here we are not able to see the target IP address is here. Target IP address is the IP address of PC number 2. Done. So this is IP header, IPv6 header. In IPv6 header, source IP will be the IP address of PC1, destination will be the multicast. Source MAC will be the MAC address of PC1, destination will be the multicast MAC address. And you already know how to calculate these multicast IP address or multicast MAC address. After that, this is the first neighbor solicitation message. Let me close this message, and then you can see the next message is neighbor advertisement message. Who have sent this message? Source is 2, means PC number 2. PC2 have sent this neighbor solicitation message. Source MAC is the MAC address of PC1, PC2, sorry, CC02 27 C0000, and destination MAC, this is unicast. Destination MAC will be the MAC address of PC1. So after receiving solicitation message, this is NS message, neighbor solicitation. And once PC1 will receive neighbor solicitation message, it will send what? Neighbor advertisement message. Neighbor advertisement message. This is neighbor advertisement message and a message, right? And in neighbor advertisement message, source MAC will be the MAC address of PC2, that is CA hyphen 0 2 2 2 7C 0000. This will be the source MAC address. Destination MAC will be the MAC address of PC1 CA hyphen 01 hyphen 57 hyphen 5C hyphen 00 right. Source IP address will be the IP address of PC2 2001 colon DB8 colon 1234 double colon 2, and destination IP address will be 2001 colon DB8 colon 1234 double colon 1. This message is unicast. Okay, so this will be the packet flow in case of IPv6. First PC will send neighbor solicitation message. After that PC will send what? NA message, neighbor advertisement message. So till now we had discussed how many messages of neighbor discovery and DP. We have discussed RA message, router advertisement. Then we have discussed RS message, neighbor router solicitation message. Then we have discussed NS message. Then we have discussed NA message. These four messages we have discussed of NDP, neighbor discovery protocol. These all messages are a type of NDP, and in all messages NDP will generate ICMP version 6 message. Okay guys, so hope this is clear. Till here it is clear to you that how packet will flow between two computer in case of IPv6. And see, both machine is now maintaining the neighbor table. So IPv6, this is similar like your ARP table, IP address and MAC address, and PC2 will also have information about IP address and MAC address. So IPv6 neighbor done. So till now we have discussed all basic things about IPv6. Now we are going to start the routing, right? So in next video I will start routing. Okay guys, if you have learned something from this video, please hit on like button. If you have not subscribed this channel guys, please subscribe this channel. We will meet soon in next video. Till then, stay safe. Bye bye.